Okay, it looks like I can. So um, this is the online office hour from 10:23. So what types of questions do you guys have?
Um, I have a question on problem two.
Okay.
When I was calculating the A-rail for the first one,
Hmm.
yeah, for that one, when I was doing A-rail, I had my normal as omega cross RA or RAE, and then the omega dot cross RAE. And I had a hard time getting to when I ended up working out. When I saw like the answer that is given, it makes sense because the U dot is in that direction in the K, and then the U squared over 3, the minus U squared over 3, that makes sense as well. But that's only the part from the circular top, correct?
Yeah, I mean that's because it's kind of like if you were sitting right here,
Yeah,
or it
yeah,
could be
yeah.
wherever, and you're rotating with this part now, right? So the question is,
Uh-huh.
what is point A doing? Because you're also rotating. You're always pointing towards kind of E there. So um, yeah, so it's just going to have like a lot of these, right? It's going to have some sort of a tangential. So it's going to have an AT
Right,
that's based on this guy, and that's going to have a normal. So it's just like if you were
right,
a spider climbing on that thing, or I think we had a couple where you had
right,
a slot and a ball going in it.
right.
So it's,
The hard thing here was deriving that U K hat minus U squared J hat from the equation. I couldn't because in my equations I had everything crossed an RAE, so that would take my like components out of like a K hat and a J hat.
well, if you were doing the whole thing, right? So we're not asking you when we say find the R double dot. This is the same, remember, as a rel.
Yeah, yeah, yeah. So
Okay.
finding the A rail, I always had my A rail came down to being omega or U dot cross RAE plus 2 omega cross U. That's what I had for the normal and tangential, basically.
Okay, so you wouldn't really do the AE here because since it's only the only circular part is right here,
Uh-huh.
right? So that's why I've kind of never gone like straight and say just go from this equation, like go from E to A, because that would be saying it's going around a curve like this. Right. So when we've had, again, I would go
Right,
back to something like this. Remember, we had some sort of problem. I can't remember if this wheel was rolling or whatever. But remember, we just went up to here and we used that type of radius instead of the whole radius. So in this case, if you're going around a curve, it's again just like a car going around a path.
Mm-hmm.
Okay. So I guess I'm not quite sure if I'm answering your
Can
question.
you
Or I'm
can
getting
you
your
like
question.
can you like from the formula? Can you show how we could get the A rail like from the formula? Because I understand that the UK hat in the answer that's a tangential, and the U squared over 3 that's the normal. But if we're doing it with regard to E, what happens to that extra space in between E and the center point that you drew, right? I don't think so.
Yeah, you might. Yeah, so nothing. There's nothing going on. That actual part doesn't really affect it at all. Right. So
All right.
it's for just having a velocity or an acceleration there. That part really doesn't matter. Okay. So,
And
but if you
if we were at point B, would there only be tangential and no normal?
yeah, what do you think?
That's what it's not a circle, so
Right.
it should be tangential.
How about if I was right here?
See?
Yep. How about if I'm right here?
Then you have the normal base to distance.
Yep. So that would be going in towards the center there.
Okay, so then deriving those values from it, how would those work out?
Um, I guess basically my only answer for you is it's just it really goes back to v squared over rho over en plus v dot t of E sub t.
Okay.
Right? I mean, I'm not quite sure how else to go about kind of deriving them. So, and
All right. Yeah.
yeah, it does. So that's why I kind of, for some of these, it's hard. You have to be able to just look and think about, okay, this is, like a normal tangential thing, or, hey, I'm going to have, you should always be thinking about, in terms of accelerations, that you can have a normal type acceleration, you can have a tangential type of acceleration. You have these rel terms, and sometimes within your rel term, like this one, you have like a normal tangent, have a normal acceleration, you can have a tangential acceleration, and you could even have a Coriolis type of acceleration depending on how you're setting your different coordinate systems, like what we have. I think there's a later one in here.
Okay.
So someone is asking about sort of the VREL, so Will's there, so both of you guys are looking there. So the R double dot is the same kind of as I wrote up there, and I think Ethan told them as well. So the R double dot I put up way back when, showing you that it's the same as the AREL. So the book uses R double dot. Professor Rossman uses R double dot for the most part. But those two are the same thing. So then somebody was asking about this one, I believe, right? So in this case, and again, it's going to depend on where you're putting your frame, right? And really, when you work these out in different ways, you get the same end answer. Like if you're going to try to find the acceleration of point A, then really you could solve it either way by, first, of course, you need to define what your axes are and what they're doing. I'm getting a little feedback, so if you guys can mute yours when you're not asking questions, that sometimes helps. So let's say if that's like our U1 and our U2, and this could be our U3, right? So then if I set my capital omega, and here I believe we've just asked you to do it, right, with capital omega setting only with the omega 1. So remember, that's like you're kind of sitting right here and you're, looking at it from that way. Okay? So then, if you're looking at it from there, right, then you're going to have a couple different types of things that could be going on, right? So the first thing that might be going, right, is because you have an endpoint here, then in your VREL types of terms, you can have an omega 2 dot crossed by an R, right? And that R would be here. So this would be like a tangential acceleration there, right? So that would be end up going like in the U1 direction in the end. Does that make sense to you?
Well.
Yeah. Yeah, I said you could have that. So in this case, right, then you could say that one's 0. So I'm trying to do in general, sorry. Right, and then what else could you have? You have like an omega 2 cross omega 2, right, cross an R of A with respect to C, right? So that's going to be a normal acceleration going in, right, from A, that would point from A down towards C. Okay, so this is now your R double dot, or your R your AREL type of term. Okay, does that make all right sense so far? Okay. Then what else could you have? Yep, so you've got some sort of U double dot, and I think in that case it was actually decelerating, right? So that would be like in a minus U2, or if you did a little XYZ if you're using that one. Okay, and then you have to also look at it in the terms of, do you see how the U is going upwards? Right, so the EU right now is going up, but that's like our VREL, right? So you're going to have a 2, and now we're going to have the omega 2 crossed into the u term there, right? Because you're just looking from here, right? And we don't include this omega 2 at all in this overall calculation, right? So let's just spread that out for a second. If we're doing acceleration of A, then you could do this a couple different ways, right? But you could do like how I would normally do is acceleration of C plus my capital omega cross R of A with respect to C, and then I do a plus a capital omega dot cross R of A with respect to C, and then we do our plus a 2 omega cross our V rel term, right? And then we'd have a plus an A rel term.
Can there be an omega cross R AC?
Well, not in this term here, right? So you're going to have. I'm sorry. Say what you were saying again. What you got to tell me which omega 2? Sorry.
Omega.
Oh, yeah. I understand. Sorry. Thank you. Right. So we've got our normal term here as well. Okay, so it's kind of like you have two different Coriolis ones, but this term right here is going to be 2, and now it's going to be the omega 1 term, right, crossed into the u. Okay, so you really end up having two different Coriolis terms. You have this one up here that's really taking into account the fact that you have the omega 2 that's changing the direction of the little u. And then you have this other one down here where the omega 1 is also changing to the direction of the u. So depending on where you put all this stuff in, right, you get the same basic thing if you had done your capital omega as being omega 1 plus omega 2, then you get the same thing, because it would basically just, here you'd have omega 1 plus omega 2, and you wouldn't have this Coriolis term up here. So you get to typically choose, right, and you should know which way all these terms go, but when you choose your capital omega, that then controls whatever your things are going to be. Okay. I think, did we do the 0? Yeah, so the u is a speed, so you're right, that should just be a single dot there. Thanks. Okay, so are there more questions on this one?
Yes.
Okay, go ahead.
When you're looking at it from point D,
Mm-hmm.
what part of that is the V rel? Part is A rel? So I'm a little confused.
The V, which is the V rel part?
Yeah, because what's the V rel for this?
Yeah, it's just the U part.
It's just the U part?
Yeah.
And if you were looking at it from point C, what would the V rel term be?
It's the same thing, right? So yeah, because remember what comes in there. If you're worried about what's going on with the omega, like here, right? That's what's you're getting, like, either that's going to come into like this term right here.
Yeah.
Those are going to come into the AC part. So you don't have to, if you're looking out there, then the length of it doesn't, the length there doesn't matter. All that's doing is maybe changing your R. That's why I always have you really go out to point C here.
Yeah.
So it makes things easier. But if you were at part D, then it does not change your acceleration or your velocity.
You're talking about the relative acceleration and velocity?
Correct.
Okay, so when you change reference frame, what does that usually change? Does that change that AC you circled before?
Well, when you change the reference frames, it's changing this omega, right?
Yeah.
So don't worry about or I've told you lots of times, don't worry that much about the origin.
Okay, because I know when we do this, like from both frames, we should end up getting the same thing.
Correct.
And just like going through the equation of the acceleration from AC and writing the whole equation down. Like I know that's the omega, and I know how to get the omega dot. If we get the same thing, I'm still confused where all those other values, if we would have done it from point C, translate it if we were to do it from point D.
Yeah, just take everything and go from C. That's how we've always done it, and it keeps you from making mistakes. Because
Yeah.
what'll happen sometimes is people will end up somehow you'll cross an omega 2, and you'll
Yeah.
end up crossing it with this 9, the 9K somehow, right? And this term here should never be within the acceleration or velocity or anything, right? Because the 9 doesn't care if you're doing an omega 2 or not. Right?
Okay, because for homework, we're like told away from a specific reference frame, but on the test, are we gonna choose? Are we gonna be able to choose our own reference frame, or do we have to do it like in the one we asked?
Well, we could ask you which way it's rotating with. You know what I mean? Like I could ask you. I could say only set capital omega with omega 1, or set it with omega 1 and omega 2, but you
Yeah.
get to choose your kind of Führer or your reference point.
Oh, okay, so even though we're given that omega, we can still choose which frame to look at it from.
Yeah.
Okay. Thank you.
You're welcome. And yeah, we always go, remember, to that, to that one we have. I mean, there's ways you can do it when you go from D, but it just gets you into trouble in general. So that's why I always go to that farthest one out.
A quick question, Ms. Dr. Self. If you have that R double dot term right there in the top left, could I have used that in the first two problems, or number 2, the first one that I was just talking to you about, and end up with that same UK minus U squared over 3?
Let me see.
For the one that we just went up.
For this one?
Yeah.
Well, I mean, you can sort of end up getting that if you're going around a curve, or if you're in a perfect circle type of thing, right? That it ends up that V is equal to R omega. So if you call this some sort of an omega, right, that it's going around through there, then you can just plug that in, and basically you get R omega squared, right? Because this R goes in there, the V squared, so you get R squared omega squared over R. So, I mean, kind of. Is that what you're asking?
Yeah, I was just wanting to use like the formula that we had for ARAIL, which is what you just wrote on the other problem, to get the same answer that R double dot. I was trying to use that formula for the previous problem and trying to get that UK minus U squared over 3 answer, and it was kind of hard because I wasn't really getting that.
Yeah, I mean, I guess I would just say if it's a particle moving through, that it's probably makes a little more sense to go with the V squared over R, right? Especially since you're given a V. But if you have perfect circular motion, right, then it should make okay sense to you that how those are related, like what I was just doing. Like if you're going around like this, then if you've got a V and a V dot, if it's an exact, and those are both the tangential ones, then you can either do V squared over rho and then just the V dot. But if it's a perfect circle, then V squared over rho is also equal to R omega squared, and V dot tangential is equal to R alpha.
All right. Yeah, that's good.
Okay. All right, so we had somebody, Jason had asked about number 3. Is that this one? Okay. Yeah, so for here, right, so as you look at how this thing's going, and you wanted to look at 3C. Okay, and in this case, all we've got going there is it's asking you to set it with just the omega 1. Okay, so we're only doing the omega 1, so that means that you're rotating around like this, right? So that's the only one that you've got going on. And the one thing you'll also notice is the omega 2 and omega 3 are actually in the same directions, right? So they're actually going in the same which direction is that? Like an I hat. Okay, so we've got that one that's going in the I hat direction. Okay, so really what you end up doing is it's kind of like you're solving another problem there, but you've got to think about the couple of different things that are coming in. Okay, so if I'm sitting here, you can actually say, well, I'm going to set up like a whole new problem. Okay, so and I'm just sort of reading through these other. Let me see here to see what you guys are all asking. So we had 3C and 3A. Okay, so let's go through that whole one and just sort of talk about how it's going, right? So once again, you can go through and sort of set up how you want it, right? So if I usually go out, reasonably far, but let's say you're just going to do, maybe let's say you set it at up in this area, and you're just going to say that that your capital omega is equal to omega 1 plus omega 2. So let's start out with that one, right? And we can look at the rels. So then we'll get down to the C as well, Jason, as we work through. Right, so if I'm just setting up here, right, up in this one, right, then what I've got going on, right, is the only other thing that's not attached to my frame is the omega 3, right? The only other rotation that's going is that omega 3. Okay? So then if I've done this as the axes that I'm looking at, right, and I've got my capital XYZ, right, is rotating with the, let's let it rotate with omega 2, and then let's set, how do I want to do? Let's let that one do omega 1, sorry. And then let's do a U1, U2, U3 that's lined up with that at that instant. And it'll rotate with the omega 2. Okay, so it's going along in that direction, right, with the capital X. And then we could do like a B frame up here. All right, so for the first one that we look at, right, so we got the capital omega equals omega 1 plus B2, right? Then what I would do is say, well, velocity of that point A up there, and then what would be a good kind of close reference point to A to go to?
O2.
Yeah, so I would end up going to O2, right? Then you're going to have a plus capital omega cross R of A with respect to O2, right? And then I would have some sort of a VA rel. Okay, so if I look at this, right, then if I'm sitting at the axes up that are attached up here, and I'm not rotating with the omega 3, right? I'm only rotating with the omega 1 and the omega 2. Okay? So I'm not rotating along with this one as well, right? I'm only doing the omega 1 and the omega 2. So then, right, everybody think to yourselves for a minute, what would I see? Would A have a V-rel with me looking at it? Okay, so the question is,
No.
yeah, let everybody think about it for a second. So if I'm not rotating with the omega 3, right, I'm only rotating with the omega 1 and the omega 2, and I'm looking there at point A, does A look like it's going to have any velocity? So on the count of 3, you guys can type in if you think it is or not. Okay. So the question is, if I'm not rotating with omega 3, does it look like A is going to have a velocity relative to where I'm sitting? So 1, 2, 3. Okay, so we got 4 or 5 people playing. So yeah, if I'm not rotating with omega 3, right, then this is going to have some sort of a V-rel, right, because I'm not including omega 3 in this, so that means I'm going to have a VA rel term. Okay.
So wait, is that actually not rotating in that small O2 with omega? It's rotating with omega. Oh, not with omega 3.
Right. So this defines how my coordinate frame is rotating, right? So
Okay.
it doesn't have omega 3 in it, so that thing would be kind of rotating downwards
All right.
with the
Okay.
omega 3. So that's how that's how I have to kind of look at that VREL term, right? And then for VO, right, if you're looking at how VO is going, right, so now your VO, does it have a velocity due to any of the rotations? Right? And it will, right, because it's going to have the omega 1 is going to give it velocity, right, because it's going to be going, it's going around, so it would kind of go in and out. So this is going to give it a velocity. So this is going to be like an O2 from O1, right, and the omega 2 is giving it a velocity, right? So this one, this whole thing right here, let me just do this. That's going to be VO2. Okay. Then because it's just like another one that you set up, right? So now when I do this one, then I've got omega 1 plus omega 2, right, crossed into my RaO2. Okay, does that make right sense, everybody, so far?
Hmm.
And then my VAREL, like you guys said, is going to equal then my omega 3 crossed into the R of A with respect to O2. So questions there. I mean, and maybe I went through this one too fast, the VO2 one, because you could even say, if you want, that VO2 is equal to VO1, right, plus my, my omegas of that. And the omegas there are omega 1 plus omega 2. So I could have just added those together there, crossed into R of O2 with respect to O1. Okay, and then if I'm here rotating with both of these things, right, then do I have a VO2 O1 REL term? Nope, so that one's going to be 0. So I'm looking between this point here, O2 and O1, right? And the only thing that's happened there, because I'm not extending or anything, and my omega 1 and omega 2 are the only thing that's like happening between those 2 points. So this is how you could like jump from point to point to point if you were, say, analyzing a robot or something. Okay, so questions on this so far?
Can I ask for clarification?
Sure.
Okay. So when we're looking at the capital omega, and in this case it's attached to omega 1 and omega 2, you're just saying that that's what our axis rotates with, and that's why we didn't include the omega 3, so that's why we have a relative.
Yep, and that's kind of how we've always done it, right? So a lot of the times we've attached our omega actually even one farther out. Like we could have tried to attach it to all the way out to A, right? And done omega is equal to omega 1 plus omega 2 plus omega 3, right? And if we had done that, then instead of this being in the REL term, we would have just added omega 3 in right here.
Okay, it's starting to make more sense. Thank you.
Okay, good. Yeah, it's just kind of where the terms end up coming in. Okay. Yeah. So then The next question is, what happens if I say, well, I want to make it just so this thing is now only with omega 1. And so now all I have going on is going to be the omega 1 part. Okay? So when I look at that, then what I start out with is I can go still again back up to to my 0.02, just like what I did before, right? So I can basically use this same type expression. Right, so I'm still going up to O2 first, and then I'm going to have my my omega 2 and my omega 3 are going to come into play for my VREL type of term, okay? Because it's going to see in the VREL, right? If I'm just sitting here and I'm going around only with the omega 1, and if I look up here, I'm going to see this thing. Or if I'm just up here and only rotating, like I said, it kind of doesn't really matter. It's all about the directions. Then from my standpoint, right, I'd have two things that were going on. One is the omega 2, right? So the omega 2 that would be going up and causing. I'm not explaining this well. Let me see what I can do. Let me see if I can get a different pen here. Sorry. So if I was doing where this is just going to be now only with omega 1, then in my VREL term, since I'm not including the omega 2, then my VREL term, right, is now going to have an omega 2, right? And that's going to be what's going on with this guy. So it's going to be omega 2 crossed RaO2. And then it's also going to be plus the omega 3 cross R of A with respect to O2. Okay, those two are both going to go in because I didn't see them, right, if I'm only rotating with this omega 1. Right, so if I'm only rotating around that axis, then I have to include the other two in there as well.
Quick question on that.
Yeah.
So why is the omega 2 being crossed with RaO2 instead of RO1O2?
So because I'm still using this as my reference point here. But you could have gone, if you want, you actually can, especially when you have axes that are actually kind of coincide, you could go down if you want to VO1, right? So if you do this, then you just have to, the reason it's really easy to make mistakes when you do it, so that's why I usually don't go all the way back to here, but it is possible to do it.
Okay.
So if you did, then then the VO1 would be equal to 0, right?
Yeah.
Okay. So then you just have to be really careful because you don't want, like I was saying before, you don't want to include, what'll happen sometimes is people will then include this and they'll cross omega 3 with this distance, right? And you can't do that. There's nothing in omega 3 that's affecting the link between O1 and O2.
Okay. Thanks.
Sure.
I have a question.
Yeah, let me check one or two things here, just in the one, so I can make sure everybody who's chatting in gets their questions answered too. So Jacob, did that make sense to you? You had the one question, and I think Matt had similar one. Okay, and then there was one a little ways up. Let me see. There was a 3A. Jason, did you figure out what was missing in your terms, or do we need to keep going through there? Okay, so let's go look through that one as well. Was there any questions left on this one right here? On what we're talking about with the velocities? Yeah.
Going back to
So I'm having a rough time hearing you.
for this rel term from A to 0.02.
Yeah.
If we were to do it from step by step, and we were then going to relate the velocity of 02 to 01, how would the BREL term look like for that?
What's your capital omega?
Our capital omega is just omega 1 in this case, correct?
Yeah, so that's what we worked out right here.
Yeah. So then we will have to do the same thing for that one, but the omega 2 cross the, would it be the length from the 01 to the 02?
Well, it's the same thing. It's the exact same. It's this, right? Because all I did was change. All I did was when I changed what this is equal to, right? Then what it changes is what terms go in here and what terms go in here. It just swaps them essentially.
Oh, okay. Okay. Thank you.
Sure. Okay. So then we had a question on, I think for C. Right? So if we get the C here, okay, and Jason saying, so that's kind of maybe what the things were. So the question is where they go in here, right? So if you look here, the VREL term, Jason, if you're doing the capital omega, right, then the VREL term goes here, right? Whereas up here, the VREL term has both of them. Right? So when you change the big omega, yeah, the VO2 still stays the same. That's just your reference point. Okay? Because it's just in this, it's the same equation, right, that I'm using is right here. What will change is this capital omega and what's going into your VREL. Right? Does everybody, did you guys see that? So if we look in these terms, right? So in this case, when we used both of them, right? Here's what we got. We have our capital omega plus RAO2 of A with respect to O2 is going to be this term, right? If I came down and I worked all that out, then my capital omega for this other term would be omega cross R AO2. Now, this term, if I only have this guy up here, where it's only omega 1, is just going to be omega 1 crossed into RAO2. Okay, so you still get, do you see, you have the same terms everywhere. You're going to have an omega 1, right? So you got, let me see if I can make a little highlighter deal. You've got an let's see. No, I want a laser pointer. Hold on. You've got omega 1 crossed R. You've got omega 2 cross R. But in this case, right, then it's in the omega cross R term, right? And then I have the VA-REL is omega 3 cross R. So I've got all of them crossed into RA with respect to O2. It just so happens that here I've got omega 2 and the omega 3 crosses are in the VREL term, versus here in the VREL term there was only the omega 3. Okay, and then the omega cross R term here is in the omega, here we have omega 1 cross RA/O2, right? So we have omega 1 cross this, omega 2 cross this, omega 3 cross this, right? It's just where they come in. We're getting the same thing. So here I got omega 1 cross this, omega 2 cross this, and omega 3 cross this, right? So all it's doing is swapping where those things occur. Okay, so there are questions, does that, yeah, so you don't do the time derivative, Jason, there. You just do, you just have to look at the same kind of R, the RREL terms, just like you're setting up a whole new problem. Okay, so do the same type of thing as if you're sitting on the end, just like what we've kind of talked about before. So if we looked at this, right, so let's just do the let's see, where do we want? We just wanted it here, right? So this guy, if here I'm just sitting on this one, right, then you can really just make a whole new type of setup, right? So all you're doing is you're going around with the omega 1. Right? So if you were solving the whole thing, right, then you could start up at O2 again and go to that like we had said. Okay, but if you are only going around with the omega 1, then it's almost like you're setting up, like I was saying, a whole second one there, right? So what you end up sorry, I'm just going back and looking at my notes again too. All right, so yeah, what you end up as you're going through, because I'm trying to remember. Okay, just with the omega 1, sorry, is you're going to end up with two different things that are going on, right? So the first one we're doing is we've got like a VREL term, right, where this guy, right, is moving through. So I'm just let me try to see how I want to explain it. So what you're going to get for this one, so you're doing the same type of thing we talked about before with going to the O2, and you're going to have all of those other terms are going to go into, you've got still an omega cross R, right? So this one would be an R, again, the O2, right? And then you'd still have a plus capital omega dot, and then you'd have a cross of RaO2, right? So those terms would be for if you're doing your overall one. Okay, and then if you're kind of sitting here, you're going to be looking up at two different things. Okay, and one of them that you're going to get is you could end up with some type of a tangential, right? But because neither omega 2 or omega 3 are changing, you're not going to get that in your AREL term, right? So you would still have some things that would come up in this VREL one, right? So you'd use your VREL that we had from before, and then so the VREL from here, right? So you'd still end up using this guy right there. Okay. But then the last one that you get, and this one's going to be I think a little confusing. Okay, so the one thing that you're going to get is because the omega 2, right? So we haven't included the omega 2 in ours. So you would get an omega 2, and let me actually just write AREL here. You're going to get like an omega 2 cross omega 2 cross the R from A to O2, right? And then you're also going to get an omega 1 cross omega 1 cross R A O2. Okay. Let me see, I had a question in there. And the omega U's in acceleration 2. It could, Jacob, but not in this, right? Because we've told you we're doing here, right? So we've told you which one to do. Like if you're doing this on the test, so I wouldn't have you go back to omegas, right? It just doesn't make any sense. You would always get, I would always start here and include at least 2 omegas and only have one other that would ever go into a REL term. So on the test, we wouldn't ask you to do the 2. So yeah, these are both normal accelerations, and one is due to this omega 2 term, right? How it's going. So that thing's going around like here, Right? And then the second one is due to this omega 3, right? So you've got this omega 3, and it's going to have a normal. Let me write this on here. Hold on. Shoot. Okay, it's going to have an omega 2 one going in like this, right? So a omega 3 cross omega 3 cross R. So you're going to have one that's going like that, and then one's going to be basically due to this one. Okay, and then the third term in there is because you've got this frame that's also rotating with respect to this omega 2. So you do end up getting a Coriolis due to that one. And the reason there is because you've got this type of velocity, right, that we had talked about before. So this is our omega 3 R type of velocity. So omega 3 cross R A with respect to O2, right? That one's going up like this, and the omega 2 here is making that one change its direction. Okay, so that one's making it change direction. So that's why we also get a plus 2 omega, which one's that? 2 crossed into the omega 3 cross R AO2. And that's pretty confusing. I don't know. We probably shouldn't really have included that one in there. I'm sorry about that.
That was kind of a quick question.
Yeah.
Why is omega 1 in the A rel wouldn't it be accounted for in the capital omega?
Oh, you're right. Sorry. That should be omega 3.
Thanks.
Thank you.
That's my question.
Yeah.
Dr. Self, if you were finding the A rel and your capital omega included 1, 2, and 3, would there be a B rel?
What do you think?
There shouldn't be, right? Because then you're rotating with 3.
Correct.
All right.
And that's
But
what
there would be an A rel.
No. Didn't you just say that?
Yeah, but the B rel and the A rel are both 0.
Correct.
Okay.
Yeah, so if you get to choose, I usually choose the one that's farthest out, right? So,
Right.
Sometimes maybe one back in, but yeah, it doesn't make a whole lot of sense to choose 2 back in. You know what I mean?
Okay. Yeah. So what are they trying to say? But with D and E, where they're trying to find omega O2A.
Oh, that's just saying what is the overall angular velocity of this link right here, right? So what is the overall angular velocity of that link? Right. So what would you do?
The overall, and then you would do omega 1, omega 2, omega 3.
Yep, you just add them together.
And then the AO2A is just the derivative of that?
Just like we've done before, right? Where you do the time derivative of a vector. Yep, so that one shouldn't be hard for you.
Yeah.
Okay, I thought a while back I saw somebody asking something about the first problem, like a 0.04 or something, and I don't remember what that was now.
I just thought, before we go there, can I ask a quick question? Those terms for normal acceleration, would that A rel contain a tangential acceleration, like the other problem, like that equals 2A?
It could, but in this case, omega 2 was constant, and so was omega 3. And they were also in the same. X hat direction, so you wouldn't have, like an alpha just due to that, right? So if you could have ended up having an omega 2 cross omega 3.
And that red part all the way at the bottom, is that considered a part of A row?
Yes.
Okay. But you said that was Coriolis?
Yeah, so anytime you see that kind of 2 omega term, that's a Coriolis term. It has to do with things changing direction.
How is that different from the 2 capital Omega?
Yeah, so that's where we were talking about this one right here. So this is an omega cross R. That's like a V, kind of a V-rel type of term. And since it's got it's got a velocity that's going up like, well, which way was that omega going? I'm sorry, it's actually going down like this, isn't it? But it's pointing down like that, but this omega 2, that's why I had that other one, is going to make it rotate. So it was pointing down, and then because omega 2 is making it rotate, it's then going to point this way, and so we get that Coriolis term now because of that change in direction.
Okay. Thank you.
Okay. All right, so yeah, Ben's asking about the top one here. Yeah, so I think actually, let's say maybe Ethan's going through there, and was this for just for the A, or do you want to look at for the B one? Okay, so you should end up getting that for it could be due to 1 or 2 different things. Whenever you have that omega 1 and omega 2 there, right? It's if you do it from the let's say we did it from the B, right? So then if you do an acceleration of A is going to equal, and then we can go through all the same old things, right? So I would generally choose C, and then you have a capital omega dot crossed into R of A with respect to C, plus we've got our normal type of acceleration, right?
All right.
And then we can do so here's kind of basically our Coriolis, right? So this is our V rel. Okay, and then we have our A rel, right? So even if we, when we look how this one's set up, right, we could start if we want with, let's say we were doing the omega. So let's start that off, and let's say we're going to let it be part B. And let's just say we're going to do both of them. So we got the omega 1 and we got the omega 2. Okay, so then if I look at these, I've got to find out my capital omega dot, right? So if I'm doing my capital omega dot, then what is that going to end up being?
Omega 1 dot in the Z plus omega 1 C hat dot plus omega 2 dot in the YX plus omega 2 X hat dot.
Okay, so we're gonna we do this one now, right? And we can say, does anything make Z change direction?
No.
All right, so that was going to be 0, and then does anything make the X change direction? I don't know if is it real? Is it Y? I mean, is it X?
Looks like it's X.
I think that's
Oh, it's in the Y. Y. Okay. Yeah, it's Y.
Okay, so then we look and see, okay, well, what's that going to change in here? So we're going to have a omega 2 is our y one, right? So I'm just going to do this term right now to show you kind of where some of these are going to come from. So we got omega 2 y, right? And what makes that change direction?
Omega 1.
Yeah. Okay, so then we've got the z cross y, right? If we look through here, so z cross y is actually a minus x, right? But we have the other minus, so that's going to give me an omega 1, omega 2, and that's going to be in the x. And then did omega 1, I can't remember if we let everything change. It's increasing, right? So we have we still have the omega 1 dot. And was omega 2 having any change? Yep, so, and that's also going, right? So we have omega 2 dot in the y, okay? So when we look through there, then we're gonna end up crossing this, right? We're gonna cross this with our r vector, right? So we're gonna end up crossing that because we're gonna go for this term up here, right? So we're gonna end up crossing this guy. So that's gonna be, and the r is 0.02, right? And that's in the z. So when we do that out, that's where one of our 0.2 omega 1, omega 2 terms is going to come out, right? Oh, yeah, the 0.02. And then, let's see, where did we get that other one? And then I'm trying to remember where the other, so that's where our 0.02 one comes in, because that's going to be an x cross a y. And then I guess I'll have to just keep doing the other ones to get out. Where I'm trying to remember where the other one pops out. Let's see. Let me see where my other one comes in.
I think the other one is in the omega cross R.
Yeah, that's what I'm sort of going through now. Let's see, we've got because you're crossing out. Okay, yeah, because we've got two terms in there, right? So we're going to have our omega 1 in the z, right, plus omega 2 in the, yeah, you're right, sorry. Omega 2 in the y, it's going to be a minus, right? And then we cross that into, right, we've got our omega 1 z minus omega 2 y, and then we've got to cross that into our r, which is still just the same u that we had from before, right? And that's in the x direction, right? So, yeah, thanks. So we do the omega 1 times the u, right? And then we'll end up getting another term with the omega 1s times the omega 2 in there. Okay, so
I have one last question. Sorry. This is I'm done with all those, but I have a quick question on problem 4.
Hold on for a second,
for the-
Aaron. Let me answer the one that's on this one first too.
Yeah.
So we've got the equation line that starts with omega 1 z again. So this term is basically that's what this guy is, right? So this is equal to that. Did I mess things up? Let me see. Sorry, I see what you're saying. So this is actually equal to this part, and then this is the whole term is a capital omega dot. Do you see there, Jacob? So it shouldn't have been equals. That was a good catch, right? So this thing here. Let me highlight that. All right. So this whole thing is equal to the capital omega dot. Okay. So Aaron, what were you asking about?
For number 4, real quickly, I'm having a hard time for B and C. That one's fine. For B and C, how do you consider, because I have for linkages for N, for B, that's C. That one for linkages, I have 6. So I have the 1, 2, 3, 4, 5, 6 in the ground, right? For N.
Well, I think, let's see. So, I mean, you got, let me get my, right, so you got 1, 2, 3, 4, 5, 6.
Oh. And why? So those are considered linkages, those triangles?
Yeah.
Okay, so that's 8. And then for the pins, then it just be 4 pins, correct?
Well, everywhere there's a circle.
Oh, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
Okay. And then there'd be no type 2s.
Correct.
Okay, so that makes sense. I just wasn't sure how to take into those triangles and those pins, and where those pins or linkages are. So that was my problem with that one. But that works out.
Yeah, and sometimes they'll do more, shapes like this just for power transmission. So you might not be able to get as much out as you might need if you were doing like a, if you just tried a simple 4-bar.
Right. And then for C, I have the same problem because I have N equals to 4, but it actually might be 5 then, right, from C to D. So that the roller would be another linkage, right?
Yeah.
So there'd be 5 N equals to 5. And then I was having a hard time getting to the degrees of freedom of 1 there. Because then if you consider that, then I don't know if that slider I considered it, you can consider as 2 type F or 2 F1s, correct? Or 1 F2?
Well, you have to do the links, right? So the slider's actually a link, right? So this guy, so that's one link, and then you have a link here, and then you have a link here, and you have a link here, you have a link here.
And then ground.
Mm-hmm.
So there'd be 6.
Correct.
So how come you can consider that one a link, that slider?
Well, because it's not just you remember when we talked about it maybe Wednesday, right? There's 2 things you can have. One is if you have a slot and something in. So let's say this is a big deal, and there's a slot, and you just have something going in. That's then a type 2, and then the pin.
Right.
Then you don't have another link, right? So it's. We did that one where we looked at the difference on if you had a piston in here. So if you had the piston, right, that's sliding in there, then the piston counted as a link, right? And then it was just 2F, because one you had a prismatic pair and then you had a pin.
Okay.
right? Versus when we did the other one, then we didn't have a link because it was just the end of the bar and there was just like a little pin and it was constrained in a slot. And this part here was just part of the ground, right? So whenever you have
Okay.
something that's big like this, then that needs to be a link.
Okay. And then there's 1, 2, 3, 4, 5, 6 F1.
This was one as well, right? So
Yeah, so there was 1, 2, 3, 4, 5, 6.
so there's a pin here, and then it also is kept, right? That's a prismatic pair. So that
So, 1, 2, 3, 4, 5, 6, 7.
Yeah.
Okay. 15, 14. Okay, and then there's no F2s.
correct.
Okay, that makes sense. That's just a little hard to visualize sometimes.
Yeah, and there's actually some pretty good online resources that you can check if you're interested in these as well to go through and look.
Right.
Cool. All right. Other people have questions.
I'm good personally. I'm hopping offline. I just wanted to say thank you before leaving.
All right. You're welcome. Have a good night and good luck on the test tomorrow.
Thank you.
You're welcome.
Thanks, Dr. Sal.
You're welcome. Any other ones? Any things that you want to look at from previous homeworks? Omega dot R. Yep. So which one's that, Jason? Or is this just a more general? Let's see. Oh, okay. Sorry. Dot. When you were saying the dot, I was thinking of omega dot. You know, like time derivative dot. Yeah. So that one was if we have a. Let's see if I've got. What'll happen there is remember. Let me see. I don't think we gave you a problem this time. Is we had something like if you had maybe one slot, one thing was going down this, and then we had another kind of 3D-ish here, and those things were maybe sliding up and that one sliding over, sort of a 3D deal, right? So what this thing is saying is that basically we're not going to, this thing, if it's just kind of spinning around there, it really doesn't do anything in terms of like VA and VB. So if we have, if we're doing VA is going to equal VB plus omega cross R, then if you remember how I was kind of standing up there and I was just moving my arm around, right? So it's rotating around my shoulder, right? And that means that essentially this term here has got to be perpendicular to my shoulder, right? So how A is going to kind of rotate with respect to B, right? As that's moving around, it's got to be perpendicular, right? If I just spin, then nothing ever really moves there, right? Yeah, like a ball and socket. So what this one is saying is hey, this is actually, when I dot these two together, that's going to end up equaling 0. Okay, because it doesn't do any good in terms of how this thing will go. It doesn't say how the linkage actually moves at all. Okay, so then that actually just makes it a nice extra equation that you get to use, right? So basically all you're saying is this plus this plus this equals 0. Okay, and you get, remember, in 3D, you're going to get 3 equations from this, right? So essentially, you can only end up getting like four 4 equations and 4 unknowns. So we have to give you enough knowns for you to be able to solve it. Okay, more questions? Okay, well, I'm gonna I'll process this thing and try to get the recording up. It does take a little bit for it to go through and do it all.